Okay, lesson 3.3, dividing polynomials. So, usually when we're dividing, we have a polynomial in the numerator, a polynomial in the denominator, and we factor and we try to cancel things out and that sort of thing. But here we're using long division and synthetic division. I don't know if any of you remember those two things from Algebra 2.
I hate synthetic.
I hate long division.
Okay, so guess what? Sometimes you get to choose, sometimes you don't. If you'll remember, well, we'll look at that in a minute, when you cannot do synthetic division and when you can. So here, we're going to take this one problem. It says to choose which one. Use either synthetic or long division. I'm going to show you both and let you choose on the ones that you get to choose on. Sometimes you don't get to choose. Notice I'm using lined paper. There's a reason for that. If you don't keep everything lined up, you can mess this up very easily. First of all, let's look at something real quick. What do you call, you need to know these words, what do you call the number that goes under here when you're dividing?
Denominator.
Numerator.
Dividend.
I got it wrong.
I think that's the only thing I remember.
What do you call the number that goes here? Divisor. What do you call the number that ends up here? Okay. And then what if something's left over? What do we call that? The remainder. Good. Okay, so if this is the case, what do you call if it's in fractional form? Where is the dividend and where is the divisor?
Divisor's the numerator.
Okay. Right? Good. So that's helpful when we're doing, to know what those things are called whenever they use those terms. Because it says express the quotient in this form. So you have to know what the quotient is. All right. So you have x minus 4, x plus 4 is your divisor. Your dividend is 3x cubed plus 9x squared minus 5x minus 1. Now you have to make sure that your x's are in descending order. If it skips one, you need to put a placeholder in there.
Like 0.
I mean, there's a way to do it without that, but I don't like to do it. So I like to put, right. So it would be like, if it was missing the x squared, you would put 0x squared. So then you go, okay, how many times does x go into 3x cubed? And however many times it goes into it, well, you'll see where it lines up, where you have to put it. What would I have to multiply x by to get 3x cubed? 3x squared. And it ends up, you put it on top of the one that it matches, right? What? Oh, I thought someone said, what are you doing? Okay. So 3x squared times x is 3x cubed. 3x squared times 4 is positive 12x squared. Here's the thing, I'm subtracting, just like regular long division, I'm subtracting all of that. So everything inside the sign has to change. So it's 3x cubed minus 3x cubed, 9x squared minus 12x squared is negative 3x squared. And if it helps you to change that sign in there so that you don't forget, you go ahead and do that. But I don't do it because it makes mine messy. So I'd rather apply it as I go. Bring down your negative 5x. X goes into negative 3x squared. Or what do I have to multiply x by to get negative 3x squared? Negative 3x. Negative 3x times x is negative 3x squared. You should get that back. Negative 3x times 4 is negative 12x. And you're subtracting all of that. Negative 3x squared plus negative 3x squared is 0. Negative 5x squared minus a negative would be plus, so it'd be positive 7x. Bring down your minus 1. And then x goes into 7x 7 times. 7 times x is 7x. 7 times 4 is 28. You're subtracting that, which is negative 29. Negative 29 is your remainder, and the way you answer it is in this form, which is 3x squared minus 3x plus 7 minus 29 over the divisor.
I remember this. Where do we do this? Is this actually...
In Algebra 2.
Okay.
Should have been the first time to see it. So, let's take a look at synthetic division. I think you will like it.
I hope not. Wait, I don't know why I mean, if I like it, I guess it's...
Okay, so what you have, you're working with the coefficients of this polynomial, and then you're working, the only time you can use synthetic division is if when this is a linear factor, which means the x is to the first power. So if this was x squared, we couldn't do it. But since it's x to the first power, this is a linear factor, linear meaning the x has the exponent of 1, then I can use this, that number, what happens is this number goes in here, but instead of positive 4, we're going to use negative 4, and I'll tell you why we use negative 4. It's going to be the opposite sign always. Negative 4. And then we put 3, 9, negative 5, and negative 1. If one of the x's is missing in descending order, you would have to put a 0 in that place, and we'll have one in a minute where you have to do that. So you bring down the 3. Bring that down, multiply. You add, multiply. Add, so there's nothing here. You bring down the 3 first, then you multiply and get negative 12. And then you add and get negative 3. And then you multiply and get positive 12. Then you add and get positive 7. Multiply, get negative 28. Add, you get negative 29. Okay? Bring down, multiply, add, no?
I lost you.
I remember.
Okay.
Oh, well,
Bring down this number first. Bring down that number first. Then you multiply to get that number.
And then you would just put the...
Then you add. Then you multiply to get that number. Then you add. Then you multiply to get that number.
And then, so for the last one, where it's negative 29, would you just know to put x plus 400?
Okay. If the last number is 0, then there's no remainder. That's like getting a 0 here.
Okay.
If there is a number, then there's a remainder. So if that's a 0, or even if it's not a 0, whatever this is your remainder. This is your constant. This is your linear term. This is your quadratic term. So I take this, so constant, linear, quadratic. 3x squared minus 3x plus 7 minus 29 over x plus 4.
It's actually really easy. Thanks, Ms. Bailey. I don't know why when I first saw that, I just...
Now, let me explain why we put negative 4 instead of positive 4. By changing the sign, if we didn't change the sign, instead of adding, we would have to subtract. And who wants to subtract?
Nobody wants to.
Nobody wants to subtract. So by changing the sign, when we go straight down, we're adding. When we're going like this, we're multiplying by this. So this times this is this. This times this is this. This times, you see?
That's going to make my life a lot easier. Yeah, really.
The problem is you have to know both ways because you don't always divide by a linear factor. For example, in this one, you cannot use synthetic division. Now let's look at this. We're going to use long division. Not just because they tell you, because we cannot use synthetic on this one. This is the divisor. This is your dividend. Let's go ahead and check and see if we're going to have any placeholders. 4, 3, we don't have 2, we have 1, and we have 0. So we're going to have the placeholder right in here. So on this one, we would have to put a placeholder 2 if it's missing, but it's 2, 1, 0, it's not missing 1. So x squared minus 5x plus 1, and then the best advice that I can give you on long division is to be neat and careful. So good luck to some of you. X to the 4th minus 3x cubed plus 0x squared. We don't have a squared term. Plus x minus 2. Does that get all of them? 4, 3, 2, 1, 0.
Actually, like this. This is calling this one. 2.
So what I have to multiply by x squared to get x to the 4th is x squared. Where will that go? Will it go above the x cubed or the x squared? The squared. So x squared times x squared will give me x to the 4th. X squared times negative 5x is negative 5x cubed. And x squared times 1 is x squared. And I'm subtracting all of that. This is the part where you have to be extra careful. If you're going to make a mistake, you need to, if you do make a mistake, go back and check where you're subtracting, because that's usually where the mistake is. So 0, negative 3x cubed plus 5x cubed is 2x cubed. 0x squared minus x squared, negative x squared. That one's a little tricky there. 0x squared minus x squared is negative x squared. Bring down your x. How many times does x squared go into 2x cubed?
2x.
Plus 2x. 2x times 2x times x squared is 2x cubed. 2x times negative 5x is negative 10x squared. 2x times 1 is 2x. And I'm subtracting all of that. 0. What will this give me?
Positive
9x squared. And then negative x? And minus 2. And then that goes 9 times. 9x squared minus 45x plus 9. And subtracting all of that. So that would be positive 44x and negative 11. And that is the remainder. So I'll come over here since I'm out of room and put my answer. That's x squared plus 2x plus 9 plus 44x minus 11 over x squared minus 5x plus 1.
Synthetic division.
I really wanted one of these to have to put a 0 as a placeholder, but I guess I didn't pick one.
Can you
So, can I pick one?
Can you make one up?
I can find one.
Do you just put one? One. Negative 1.
4, 3, 2, 1. I could just take out the X. I could do that. Let's just act like this isn't here.
You can't just do that as well.
What?
You can't just delete them.
I know, it bothers me.
So do you just put like 1 and then negative 1 and 1?
There's one. It's an easier one, but I can do that.
Well, we put 0 as well. That's what I'm really curious about.
You put, just like in this one, where we had to put a 0, you'll put a 0 in the place where it's missing one. So, I'll do one. Let's do number 28. We'll just do that one instead. So 4x squared minus 3 over x minus 2. Synthetic division. It's missing the linear term, so I have to put 0 here. Brought down my 4, I multiplied, add, multiply, add. So this is my remainder, this is my constant, and this is my linear term. So 4x plus 8 plus 13 over x minus 2.
Can we do 32 still?
Mm-hmm.
Just
Since it's, the only thing about having that lined paper is I cannot move things around. So once you get that, I'll erase it. I can't erase it. Is anybody still writing that? Ready? Bring down, multiply, add, multiply, add, multiply. Ready? 1, 5, 4, 20, 21,
105. 520.
This is the remainder, which means this is your constant, linear term, quadratic term, and cubed term. Okay, so you have x cubed plus 4x squared plus 21x plus 104 plus 522 over x minus 5.
2600.
Hmm?
use just add them.
Yeah, first one, like the number, first one is the coefficient of it. It is the, and the coefficient of it, and it's the one.
So, let me pause this just for a second. One more problem and we're finished. What if you have to work backwards? Find a polynomial of the specified degree that has the given zeros. It's way easier than you think.
Oh, okay.
Or I think it is. If negative 2 is a 0, what is the factor? What did it have to be for me to say that x is equal to negative 2? One of the zeros is negative 2. What did it have to be?
Oh, 2.
Positive 2. So this factor would have yielded a negative 2 as a 0, right? What would give me 0?
Just X.
X. I like to put those out front. If there's a 0 there, I just put the X out front. And then this factor would have been,
X minus 2.
and this would have been,
X minus 2.
and what they're wanting you to do is multiply that out. And you can do these two first, then this, but what I'm going to do is what I know quickly what this is multiplied together. Do you?
X squared minus 2x.
So that way I took care of that binomial quickly. And then distribute the x. And then all I have to do is use the FOIL method here. That's x to the 4th minus 4x cubed minus 4x squared plus 16. And I believe that's it. Did I do what they said? Find the polynomial of the specified degree that has the given zeros. Has a degree of 4, and here are my zeros. Hmm? Oh, yes. Thank you. Yes, I left my x off. There it is. Got it? So long division, synthetic division. If you have a choice, which will you use? Synthetic?
Long division.
Long division? Well, the thing about long division is you can always fall back on long division with regular numbers if you forget what to do. Synthetic is something, if you haven't seen it for a while, you're like, okay, do I add, do I subtract, do I multiply, what do I do? So it just takes practice. All right, there's your assignment.